Have you ever really thought about what happens before you press an elevator button? I mean, what it really takes to get you from one floor to another. Well, it's a journey that's way more complex and precise than you'd probably imagine. And it doesn't start with steel and cables. It starts with a simple drawing. Today, we're pulling back the curtain on the hidden story of how an elevator goes from just a blueprint to a working button.
You know, we do it every day, right? We don't even think about it. But this little button, it's the very last step in a massive, massive feat of engineering, construction, and just meticulous planning. So what really is behind it? What does it take to make sure that when you press it, you get a safe, smooth ride every single time?
All right, let's start at the very beginning, going from blueprint to reality. Because the story of a safe elevator, it doesn't begin on a construction site. It begins with an incredibly precise plan, all laid out on paper.
Yeah, and these blueprints, they aren't just suggestions or nice-to-haves. They're a legal document. They have to be approved by the city, and once they are, they officially carve out the dedicated space for the elevator right into the building structure. This document, it becomes the absolute source of truth for the entire project.
Okay, so let's dive into what's actually in those blueprints. We're going to look at the three core components. These are the critical, totally non-negotiable spaces that form the elevator's entire infrastructure. First up is the pit. This is the area at the very bottom of the shaft, below the lowest floor. And it's not just some empty space down there. It's a vital safety zone. It's where you find the buffers. You can think of them like giant shock absorbers and other critical safety gear. The depth of that pit has to be calculated perfectly based on the elevator's speed and design.
Next, we've got the shaft itself. This is basically the elevator's own private highway, the vertical path where the cabin and its counterweight travel up and down. Now, for that ride to feel smooth and quiet, the walls of the shaft have to be perfectly vertical, or plumb, as they say in the business. And the tolerance for error here is razor thin. I mean, a deviation of just half an inch over 10 stories can make a ride feel bumpy and cause some serious long-term damage. And finally, there's the machine room. This is the command center, the brain and the muscle of the whole operation. It's got the motor that lifts the car, the control panel that tells it where to go, and all the electrical systems. And its dimensions are super important, not just to fit all the equipment in, but to make sure technicians have enough space to safely do maintenance for decades.
So, the plans are approved. Now for the fun part, turning that blueprint into a physical reality. Let's walk through the key construction stages. The whole process really unfolds logically, starting from the ground up. First, the pit's foundation gets prepared. Then the shaft is built with that extreme precision we were just talking about. After that, the doors are framed in on each floor, followed by installing the guide rails that the car actually runs on. And finally, the machine room gets all set up with the motor and the control systems.
Now, you might be thinking, it's a concrete pit, it's probably fine, but waterproofing here is absolutely non-negotiable. See, any water that seeps in from the foundation can cause rust on critical parts, and even more dangerously, it can lead to short circuits and cause the sensitive electrical safety systems down there to fail.
And those guide rails? They are the secret ingredient to a perfectly smooth ride. If they aren't parallel down to the millimeter, you're going to feel it as a vibration. And over time, that tiny little misalignment creates so much extra wear and tear on the moving parts, leading to breakdowns and really expensive repairs down the line.
So what happens when things don't go according to plan? Let's talk about some common challenges, because in this world, a mistake of just a few millimeters can create some massive, massive problems. And what's crazy is that each of these issues creates this costly ripple effect. For example, if the shaft is built just a little too small, you're suddenly forced to order a smaller, custom-made elevator, which costs a fortune. If the shaft isn't perfectly plumb, well, the only real fix is major construction work, tearing down and rebuilding walls. And if water gets in the pit, the whole thing has to be drained, dried out, and the entire waterproofing process has to start all over again.
And here's another huge headache that trips people up all the time: power. Most modern elevators need a really heavy-duty three-phase electrical supply. It's actually a pretty simple thing to plan for early on, but if it's forgotten, trying to run that kind of power through a building that's nearly finished is just a logistical and financial nightmare.
So all of this, all these stages and challenges and solutions, it really all points back to one single overarching theme. This is the ultimate guarantee of safety.
Look, safety is not an accident. It's not luck. It is the direct result of a relentless, obsessive commitment to precision. It starts with the architect's pen, it's carried through by the construction crew, and it's finalized by the technicians who install it. Every single person in that chain has to be obsessed with getting it exactly right.
So the next time you step into an elevator and push that button, Maybe you'll think about that waterproofed pit deep below you, the perfectly plumbed shaft all around you, and the precisely aligned rails that are guiding your way. Maybe you'll think about the hidden story of precision that makes your simple, everyday ride possible.